Okay. Um, awesome. So, okay, let's go talking mode. Yo, hey everyone. It's Gabriel Holden, and we're here again after yesterday. Super stoked. Alexa, create a 12:10 a.m. alarm. Oh wait, no. Alexa, cancel. Alexa, create a 1 hour timer.
1 hour timer started.
Yeehaw. Okay, and we're gonna get some lo-fi music going. I'm kind of curious where Timbit's dog walker is, because she's normally picked him up by now. Um. Anyway, so yeah, so we're picking up from yesterday. Super stoked, super stoked, and probably got about an hour on this one, as illustrated by me making a 1 hour timer. Um, so what are we up to? So today we are going to hack on some stuff. It should be super fun. Um, yes. Um, what am I doing? Right. Okay. So yesterday we went down the path together, all of us. It was fantastic, so much fun, and we ran into some fun problems. And by some fun problems, what I mean is there was a interesting feature. Okay, yeah. So essentially, int and big int are not the same thing inside of Spark SQL, which makes sense, right? Like they're different things and they have different ranges. Um, so we found a first bug, which was everything was getting converted to a string when we were dumping the Python AST. We fixed that bug, and then after we fixed that bug, we found it was still failing, and we found it was still failing because int and big int aren't the same. And this was definitely 100% not what I was expecting to be the cause of the problem. Right, I was very much expecting different things. So I thought it was an issue with the children nodes. It was not. It was definitely not. Um, and it was some other stuff. So let's go ahead and we are going to look at our code from yesterday. And I actually wrote a note. So some hacks should we explore using the expression resolver to upgrade? And like that seems like a thing that we might want to do. Let's go ahead. Um, and where we're going to do this, Python udf.scala. Okay. Um, I'm really worried about. I'm sorry about Timbit's dog walker because she's normally here like well before now. Um, hey dear. Oh well. Okay. We will deal with that. She's probably just running late today. This might pose a slight problem because I had to schedule Jenga some other stuff around. But we're gonna make it work. Normally it doesn't matter too much because Carolyn and I are both home, but because it's just me today, through the end of the week, it's a little bit more tricky. But we are going to make it work. Um, Professor go? No, okay. Um, and so our note said maybe we should use the resolver and expression. Resolver. Okay. Expression resolver dot resolve. I mean, that seems like a thing that we might want to do. Um, where is this expression resolver instantiated from? Like, how do we get the expression resolver? Expression resolver. Okay. Where are you used? I guess. Or do we need the full expression resolver, or can we get away with just resolver? Let's go take a look at resolve. Okay, this looks like some non-trivial code, so I don't want to copy it. Let's find where expression resolver is used and see if we can steal it. Um, um, we have a lot of expression resolvers. Damn it. Um, Fiddlesticks, as my mother would say. Okay, well, there's the resolver inside of resolver on Scala. Let's go take a look at resolver. That's Scala. Okay. Um, oh, logical plan resolver. We get away with like a more minimal. Damn it. Okay, that's weird. Oh, it's a type definition, which is a tree node resolver. Oh yeah, it's gonna do jack shit for us. Although you would think LSP would have been able to find it, but okay. Questions not for today. Um, okay, I was really hoping we could just go ahead and grab expression resolver because I don't actually really need to resolve anything. I just need to fix the types. The thing is, the type fixing or type upgrading, pardon me, happens inside of the expression resolver. Um, oh, be right back. Okay, great success. So let's keep digging into this. So, oh, coerce expression types? That looks coerces expression types, my friend. Is that courses expression types dot scala? That might be the only thing that we need. Ah, it's trait. God damn it. So it's essentially abstract bicycles. Oh, so we can't just like, oh wait, no. Here's an object. Oh wait. These are probably the transformations that we want, realistically. Worse expression types. Okay, maybe that's what we need instead of maybe this is what we can get away with instead of the flow resolver. Okay. Subquery expression resolver. That's maybe too big, but maybe okay. This is a trait. Um, um, UDF type versus expression types. Yeah. Oh. Cool. No. Do I have SBT running somewhere? Looks like I do. Let's find it. It's not gonna be here. It's not gonna be here. It's not gonna be here. These will have SBT, and then I can grab it, and that'll make my life so much easier. Scripts. This is all of my like time projects. Oh yeah. Wait, do I have a second terminal instance running somewhere? What? Oh. Ah. I do have SBT running, but it's running from Bloop, which is the thing that helps provide autocomplete for Scala. Okay. So I don't actually have it up and running. That's fine. That's fine. Oh god, I'm so tired. Ugh. Oof. Oh. Scala style bullshit. Fine. That compiled. I really wasn't expecting that to compile. Okay. Okay. Convert to Catalyst. Okay. Um, Hmm. This looks weird and it makes me unhappy, but I want to get it working, so we're gonna dot. Is apply once actually part of? Yeah, I don't think that is. I have to go to the tree traversal though. Um, Damn protected. Doot. Catalyst extra. Okay. And then we're gonna go ahead, Catalyst expert upgraded. Upgraded. Okay. Um Upgrade the types here. Um yeah, since Python types um since um uh, Python types map narrower types and then um but return to do um, clarify that so it makes sense. Okay, cool. Oh yeah, okay. Oh. Hmm. Okay, yeah. Wait, what? Oh. But get implicitly since Python since the type of a since Python duck typing means that Python, the types for EG4 becomes L for I think that actually makes enough sense. I can drop my to do. Have that make a little bit more sense. Okay, 9. Ugh. And our good friend Jolt Cola will hopefully help keep me from yawning too much. Okay. Hopefully this type promotion thing works. Okay. Oh yeah, okay. And then so to do you should avoid converting a UDF node where that would break pipelining. UDF, UDF, UDF. Cheaper is often cheaper than UDF. Catalyst, UDF. But if we can convert which way? Cool. That's a more complicated to do. Oh, I don't think I'm anyone's mom, but okay. Cool. Uh, Probably. Maybe not. Know what they say. Um, but I bet icon 2020. See here, 2020. Well, if that's the date that they were born, let's see here. Do I remember what I was doing 5 years ago? Not really. So, you never know. Never know. Okay. But let's go ahead and give this a shot. Now, pin spark submit UDF sanity. Cool, it still fails. Why is it still failing? I thought we upgraded it. Did we not upgrade it? New expert. Okay. Um, uh, New expert upgraded. Input data types check. Oh, right, I didn't run package, I just ran compile. So, compiled it, but we need to package it into jars so that we can actually run the test. Okay. Cool. Now let's run it. Yeah, it fucking works. It fucking works. Bang. Fuck. Okay, sorry. Cool. So that worked. We transpiled the UDF. That shit worked. I'm really stoked. Okay. Um. Okay. Uh. Fix. Type upgrading. Add type upgrading. Cool. Cool. That's awesome. So, well, let's leave those in there for now. Okay. So we've got this to do, which is definitely something I want to think about. It's gonna be gnarly to implement because I'm lazy. Yeah. Okay. So in fact, what we want to do here, probably, so the problem is like we want to look on either side of us in the tree. So if we're transforming down, it's difficult to look at our parent. If we're transforming up, yeah, okay. If we're transforming down, okay. So my thought here is essentially we want to try and write some logic to do this thing that I think we should do. The reason for that is that that's the reason why we want to keep these nodes as things which could either stay as UDFs or become catalyst expressions, depending on the context. So, doing that's kind of a pain in the ass, mind you. And I guess that's why it work. Okay. Well, let's get the treadmill going. Oh. Okay. Oh. Oh. Let's get the treadmill going. Okay, so let's go take a look at our friend. Oh, we could have just called logical plan resolve. Maybe. No, whatever. We'll deal with this another time. Okay. Oh. Still. We've got a logical plan. And we want to do stuff to expressions. So. Wait. Is that resolve? Oh, maybe it's not. No, it is a logical plan. Oh, okay, so that means it's coming in from somewhere else, right? Really? Fucking LSP. What? You are not serving me well today, my friend. Don't probably do a like trying to fix my Emacs setup at some point. But okay. So I don't think we can use with pruning. And I think unfortunately we're gonna have to rewrite this. Um, in like a kind of annoying way. Um, yes, as Carolyn says, the time scores almost are terrifying. So, um, what are we going to do? So we are going to. Okay, this is our core like magic. But now we need to do more smart things. Okay, so essentially we want to avoid switching things in the middle where we haven't been able to switch the top or the bottom. If we can switch the top or the bottom, then we can switch the middle too. Yeah. Okay, so what we would do, let's go look at resolve expression down with pruning. Resolve expression down. So I think we're gonna go and write. Okay. So if the parent um, okay. Bloop, 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 Utilities parent is UDF. Cool. False. Oh. Oh. Resolve operators. Transform expressions. Transform expression. Uh, okay, okay. Um, Transform down is the same thing as transform down with pruning. Let's go find transform down with pruning. Um, okay. Filter cons, and then go okay. Yeah. Okay. Um, so this says if this condition doesn't apply, return immediately. But that doesn't, because we, okay, well, whatever. Um, okay, let's go look at analysis helper. Transform down with in analyzer use resolve operators down. Okay, fine. Transform down with pruning. Partial function, logical plan, logical. What's your super query plan type logical plan? Is there another helper that we should be using instead? Okay. It does extend tree node. Okay, so do here, I'm guessing. Um, if actually, yeah, it seems short circuit if there is no Python UDFs in the plan. Otherwise, plan So in that case, what we're doing here, I don't actually want to transform down with pruning per se. Okay, so this is our rule, but our rule is a little funky. Um, so plan um so if we don't manage to convert ourselves to a UDF, then from a UDF. Okay, so here we go. Map children by underscore parent is UDF is equal to true. Otherwise here, catalyst expert upgraded dot map children apply parent is UDF is equal to false. Right? Case. Oh wait, no, we do this only if the parent is not a UDF. False. Case underscore. Yes. I think that's what we do. So, does this make sense? That's really the big question. I don't think I know the answer. But okay, let me. Okay. Where that could break pipeline. So if we are unable to check ourselves, we still want to try and change our children. Yeah. Like, okay. Oh. Maybe this feels like I'm. Yeah. Okay. Uh, um. Yeah. Okay. so that's the thing here, right? This is not quite what we want, right? Because if we go and look inside of um, let's resolve operators with pruning, resolve operators up, and then resolve operators with pruning. Resolve expressions with pruning. You're saying you can't find resolve expressions. Literally here. Okay. And you call resolve operators with pruning. Really? In the same fucking file. What is this? Why is LSP having such a hard time? So resolve operators with pruning returns a logical plan. And it does this by calling resolve down with pruning. So you take a partial function of logical plan. Okay. Which you also take, okay. Resolve expressions with pruning. Calls resolve expressions down with pruning. Which takes this rule from expression to expression. And you say resolve operators with pruning. And this is the part where we switch from expression to expression to tree, right? Because if we go look at resolve operators with pruning, oh yeah, okay. And then this is calling it on the logical plan. On the query plan. Okay. And the query plan has transform expressions down with pruning. Map expressions. Okay. Yeah, let's go take a look. Okay. So then we're going to go over here to our optimizer. Plan parent is UDF. Okay. Accepted set plan. Dot map expressions. Doot. I want to say that's what we're doing here. Maybe I'm. Nope. Uh. No, you're supposed to give back an expression, right? Found expression required. Eh. Fudgesicles. Fudgesicles. Okay. Um. Um. Okay. By. Um. Maybe yeah. That's promising. Apply it. But I don't want to do a recursive transformation. Okay, let's take a look. So map expression says, yo, what's up? Okay, and then okay. But this I only want to apply it at this node. Fuck. Because like the recursive map product. So map expressions doesn't quite do what I want because it does this recursively. And I want to do some things that are a little more funky. So yeah, okay. Actually, yeah. That compiles, but it's okay. Alright. Compiles, but map expressions does the recursion. So yep. And then so let's go ahead. I go back to our well. Actually, yeah. Yeah. So map expression. So okay, map expressions. So what we actually want to do here is do like a level map on the expressions, and then also recurse down if it's not an expression. So def recursive transform arg of any returns any ref arg match. So if it's an expression, do we? Oh, actually, maybe backup expressions is what we want. Actually, yeah. So here we go. I'm thinking map expressions might actually be what we want because as I'm looking at this, right? Yeah, this recurses down inside of everything else, but it doesn't recurse down inside of an individual expression. So if an expression has a bunch of expression as children, that's up to us to recurse down inside. So this is actually probably what we want, I think. Okay, yeah, actually, I think this is what we want. Cool, let's see if it works. Compiles. I think map expressions will recurse down everything, which is not an expert, which is what we want, but we should add some tests for non-convertible UDF, convertible UDF, non-convertible UDF. Okay. Alexa, stop. Cool. So oh, 1 second. Be right back. I might have what I need. But okay. So I think this works. Let me rephrase this. I I believe that this may have a valid, so like this may do what we want. It may also not, but like it, I'm able to talk myself into believing that this is doing what I want it to do, and at least it runs our very basic sanity check. So that's good. It's a little bit afternoon. I've got a 12:30 that I should get to, so I think this is a good time to call it. Let's see if I'm going to be able to come back in the afternoon. Let's take a look. What's my afternoon look like? Oh, okay. It's got 2 o'clock, so let's shoot for 3. So yeah, I'm gonna try and be back online around 3, and we'll look at adding these tests. Probably, honestly, I'm lazy, so we'll look at using AI to write these tests. Because like I don't super trust AI for a lot of things, but I'm much more okay with them writing like kind of annoying unit tests. So we'll see if we can get it to do that. I don't know if we will. Yeah, I'll have to fire up VS Code probably. Anyways, okay, yeah. Thanks the Icon 2020 for chatting. Thanks everyone for watching. I'll see some of you this afternoon. Um, have a good one. We're gonna keep